In January 2025, the Eaton and Palisades fires tore through Los Angeles. By the time the smoke cleared, 30 people had lost their lives, and 16,000 homes and businesses were reduced to ash. The financial toll was staggering. Estimates put the economic impact on the LA region at up to $131 billion, making it one of the costliest natural disasters in California's history. As wildland fires push further into populated areas, the immediate reaction is to look for a specific driver. We need to know why one street is wiped off the map, while the next one over is left completely untouched. Mapping the exact mechanism of this spread is where researchers are now looking to identify the vulnerabilities in our current urban planning. The most common assumption is that trees are the primary fuel source. It makes intuitive sense. A forest fire burns trees, so keeping trees away from houses should keep the houses safe. That logic is the foundation for policies like California's Zone Zero mandate. It requires homeowners to strip all vegetation within 1.5 meters of their property, creating a barren ring of defensible space. But here's the problem with that approach. Even in neighborhoods that meticulously followed these clearance laws, the houses still burn to the ground. To understand why those homes ignited, a research team out of Cal Poly conducted a massive forensic investigation into the Eaton and Palisades disaster zones. They built a massive digital map of the destruction, plotting over 15,000 building footprints across the burn area. Then, they overlaid the locations of nearly 53,000 tree canopies that existed among those exact buildings before the fire hit. By taking footprint data and cross-referencing it with damage reports and LiDAR scans, the researchers could trace the precise path of the flames. With that massive pool of data, they could finally run statistical tests to see whether it was the trees carrying the fire or the houses themselves. The team ran a simulation to see what would have happened if every single tree within 2 meters of a home had been cut down before the fire started. This chart shows the impact of extreme clearance. Next to the massive projected home losses, removing all trees saves an almost invisible sliver of homes. However, when accounting for building density, destruction probability spikes sharply upward for every additional neighboring structure built per hectare. The data shows that once a fire gets into a densely packed suburb, it stops behaving like a forest fire. Instead of jumping tree to tree, flying embers transfer roof to roof, catching in gutters and attic vents. The physics of the fire shift. It becomes an urban structural fire, where the houses themselves are the primary fuel source. If clearing urban forests offers almost no real protection against these fires, then chopping them down means we are sacrificing their environmental benefits for nothing. Those canopies provide crucial ecological services to a city. They block the sun, lower local temperatures, filter out air pollution, and trap stormwater runoff. Treating those trees as the enemy strips neighborhoods of their livability while giving homeowners a false sense of security against the next big blaze. Rather than fighting the nature around our homes, the data suggests we need to fix the homes themselves. That means relying on engineering. Builders can use fire-resistant roofing materials and install specialized mesh vents designed specifically to block flying embers from entering an attic. It also requires smarter urban planning. We can increase the physical spacing between structures and strictly enforce regular maintenance, like clearing dry leaves out of gutters. As climate change accelerates, extreme dry spells and high winds are going to push these massive fires further into densely populated areas. The defense against these disasters isn't turning our neighborhoods into barren landscapes. It is building smartly engineered infrastructure resilient enough to survive alongside nature.